give us a short introduction to your research.
So in our research, we study properties of materials at very high pressure and temperature, very extreme conditions of the order of millions of atmosphere and thousands of Kelvin, in order to understand how they behave. And this helps us to understand, for example, how matter behave at the interior of planets. And in particular, we study, in this experiment, we were studying water and mixture of water, ammonia, and carbon in order to understand and to constrain better the model of the ice giant planets. And in particular, for example, water is behaving very differently from what we normally know as liquid water, transparent liquid water. Indeed, at these extreme conditions, water becomes metallic, or even a very strange phase, which is called the superionic phase, which is something between the liquid and the solid. And this can have a very deep impact in our understanding of the ice giant planet's magnetic field, for example.
How can the HED instrument help you learn more about interior conditions of ice giant planets?
Yeah, the HED instrument of European XFEL combines two very fantastic machines, I would say. So first of all, we have a very energetic drive laser, a very modern drive laser, where we can reach our conditions, gigantic pressures, very high temperatures, and this is the machine where we can do this the most often per time interval in the world. Yeah, so we can create these conditions, and at the same time we need to probe these conditions, and there we have the other machine, the European XFEL, which is also unique in the world. They can shine its X-ray light through our samples, and we can see X-ray scattering features, and they tell us what kind of phase transition, what kind of chemistry is going on under conditions that are present in the deep interior of planets.
How can learning more about planetary interior conditions help society in the future?
Yeah, first of all, there's some philosophical background. We better understand our universe. We can help planetary missions like space probes. Actually, there's one that is currently planned to go to Uranus relatively soon, hopefully. Yeah, with relatively soon in maybe 10, 20 years or so. But our experiments resemble those conditions that we have inside those planets in the laboratory, and can help to interpret the data, also help to design those missions. So we learn more about our solar system, how it has been formed, how our Earth has been formed, and at which type of planets also life could be possible outside our solar system. Then there's also a second aspect. We investigate materials under extreme conditions. And here at the European XFEL, it's the worldwide best capability, I would say, to do so. This is interesting, for example, for chemical reactions that can produce interesting materials via these extreme conditions, for example, nanodiamonds. We study here the formation of diamonds and other interesting phases in the interior of planets, and maybe these can be also useful then for technical applications. And then other things or other applications for matter under very extreme conditions is now also in everybody's mind, could be like a clean energy production via fusion energy, for example. In this aspect, also our experiments give some information how to design those experiments in the end.